Hi guys, this is your video for our beginning of conic sections and then also specifically parabolas. So a conic section is something that you might have heard before or have seen, but now we're really going to dive into the details of it. You can see that if you have two cones that are vertically touching vertex to vertex, we can find these conic sections. Now, these sections are found by planes intersecting these cones. And now you can see here, this plane right here is fairly flat. It's not really at an angle. And it's creating a circle. And you can see that by the little orange circle that's highlighted. Over here for an ellipse, it's that same idea where we have a plane intersecting a conic, but now it's intersecting at an angle. It's no longer a circle, it's more like an oval, which mathematically we call an ellipse. Today our topic is going to be parabolas, and that's also from an intersecting plane at an angle. It's still only intersecting one of the cones. So you can see we just have that one U-shaped parabola, and then we can also have what's called a hyperbola. And that's if this plane is intersecting both cones at one time. And you can see that it's almost like we have two parabolas that are going away from each other. And we've seen that before with rational functions. Their shape is sometimes a hyperbola. So let's get into parabolas specifically. So we, for the most part, have been dealing with parabolas that have a vertical axis of symmetry. So a parabola that is either facing up, smiling, or facing down like a frown. So you would see it either like, whoops, that's way too thick. Let's fix that. So facing up or facing down. So you will see that we have a new version of standard form. So this is what we call standard form. And with this form, it's a little bit different between, now we see that K is actually included with our Y in our parentheses. And we also have that value in front is 4P. So this is a new idea. This is the first time we're seeing it. And that's going to help us find two more pieces of information, our focus and our directrix. So those are our two new words that we're going to be working on today, our focus and our directrix. So feel free to pause the screen, copy these notes down. You're going to want to be able to reference your standard form. Now remember, this is a vertical axis of symmetry, and we know that because our x term right here, that's the one that's being squared. If our y term was being squared, then we would have a horizontal axis of symmetry. So that's what's going to be on the next slide. So here we are with our horizontal axis of symmetry. Very similarly, this is called standard form. And you can see that in this standard form, now our y is being squared. So when the y is being squared, it's a horizontal axis of symmetry. And then this can also be facing like open to the left as well. So you can have an open to the right and an open to the left. Now keep in mind, these are not functions, right? This would not pass the vertical line test. We're looking at them more as a conic section because circles are not functions and ellipses are also not a function. So these are just ideas and ways that we can input information on a coordinate plane. So again, you have a focus and directrix with a horizontal axis of symmetry. So pause the screen, copy it down, and then we're going to do some examples. All right, so you will find that for the most part, our questions are asking us to graph these parabolas. We also need to find our focus and directrix. So let's take a second and talk about what this focus and directrix are. Okay, so these are going to be a couple notes for you in this example. So your focus, it's going to be a point, P units, away from the vertex. And I'm going to put in parentheses here that it's going into your parabola. So I'm going to say on the inside of parabola. Okay, so our focus is a point P units away from the vertex on the inside of our parabola. Our directrix Oops, let's just erase that. So our directrix is actually a line, p units away. You probably have the good idea here. It's going to be away from the vertex. And that's going to essentially be, we can say that's like on the outside of parabola. So these are important figures. They're not just making you draw an extra point and a line for any sort of reason. So when we're looking at a parabola, it's just a rough sketch here, and we have our vertex, we would have a point that's on the inside. So this is what's called the focus. And then you have an additional line on the outside. This is what's called the directrix. Okay, so if I were to be able to count these, if I could count the distance between my focus to my vertex and between my vertex to my directrix, they would be congruent. Okay, so the measure is exactly the same from the vertex to the focus and from the vertex to the directrix. So that's actually the whole idea of a parabola. Okay, so a parabola is going to be a set of points equidistant to its focus and directrix. So when you have this parabola, if I were to be able to measure again, if I could measure from this point on my graph to my focus and to my directrix, now clearly my picture is not so even here because it does not look congruent, but these would be the same measure, and we'll use just 2 hash marks. So that's kind of essentially what a parabola is. We know it more of like, we know it as a U-shaped graph and as a quadratic function makes a parabola, but this is what that means. Just like how we can explain absolute value a little bit more in depth, now you can explain parabolas more in depth. So I'm going to erase this, make sure you guys pause and copy this down, and we are going to work on this example problem. All right, so in this example, we see that we have, it does not look like a quadratic function, but it is. We have negative 2x squared equals 16y. So our goal is to get this into standard form, and then from standard form, we'll be able to find our vertex, our focus, our directrix, and we'll be able to graph this function, or this parabola. So standard form, so this is a vertical axis of symmetry, and we know that because when we're looking at it, we can see that our x is our squared term. So this is going to be a vertical axis of symmetry. And standard form for that is x minus h squared equals 4p times y minus k. All right, so that's our standard form. Now what we have, we can make it look like that. So we can get our x squared just as x squared. So right now we have negative 2x squared equals 16y. I can get rid of that negative 2 by dividing, so I have negative 8y. And then if you'd like to, you can even write this where you kind of have your placeholders for your h and your k. So we could write this as x minus 0 squared equals negative 8 times y minus 0. So those are just placeholders, but we can see that that's really the value of our h and our k. So we should be able to find our vertex pretty easily. And then from that, we'll be able to find our focus and our directrix. So let's start with our vertex. So our vertex is h, okay? And for us, that's just going to be 0, 0. Now we can talk about our focus. To find our focus, we need to find our p-value. So we know that the value in front of our y terms is going to be 4p. So if I were to look right here, I could set negative 8 equal to 4p. So we need to do that first. So we're going to set negative 8 equal to 4p. Do whatever you need to do to solve for p. For instance, we just need to divide. So negative 2 equals p. So this is a little strange, right? It's negative. Just keep in mind, when it's negative, that just means now your graph is facing down. Okay, so you have your vertex and you're going 2 units down for your focus. So if I were to go 2 units down from my vertex, my x value is staying the same. My y value is now negative 2. So that is my focus. So this is 2 units down from vertex. Okay, and we know it was down because it was negative. So now let's look at our directrix. Okay, so our directrix is going to be 2 units to the other direction of your focus, your vertex. So the best way to think about that is it's always the line, your vertex, the y value, put that in there. So y value of your vertex and then minus p. So for us, we have our y value of our vertex, which is 0, minus, and our p is negative 2. So you can see that our directrix is going to occur at y equals 2. It's going to be a horizontal line, so you're going to see it as y equals 2. Let's put this on a coordinate plane. So when you're making your coordinate planes, make sure that they're clear enough that you can label all of these different pieces of information here, because that's all part of your solutions. So the first thing that we could copy down here is our vertex. So that was 0, 0. So we can put our vertex on 0, 0. We know that our focus was at 0, negative 2. So this is our vertex. This is our focus. And then we also know that our directrix was the line y equals 2. So I'm just going to draw this as a dotted line. It's one of those things, it's kind of like an axis of symmetry. It's there, you use it for reference, but you don't actually draw it like a solid line, like as if you were drawing a function. So I made it a little bit bolder so you could see it. And that is our directrix. That's the line y equals 2. Okay, so it's our directrix. Alright, so clearly this does not look like a parabola. I know. So what you could do is you can plug in a couple extra points. Personally, I'll just choose points on one side and then mirror them to the other. So I'm just going to write our equation down here again. It was negative 2x squared equals 16y. And we just want to try to get this all by itself. So if I plug in 1, when I plug in 1 here, I have negative 2 times 1 squared equals 16y. So negative 2 equals 16y. So that would mean that negative 1/8 is my y value at 1. That's pretty shallow there. Maybe like right around there. Let's do another one. So let's plug in 2. So we have negative 2 times 2 squared. And it's supposed to equal 16y. So we're just finding additional points. So we have negative 2 times 4 equals 16y. We have negative 8 to equal 16y. So negative 1/2 equals y. That one's a little bit easier. Still a tiny fraction. Let's do one more just for good measure. We'll do a bigger number. We'll do 8. Okay. So we have negative 2. No, let's do 4. 8's a little too big. So we'll do negative 2 times 4 squared equals 16y. And that means we have negative 2 times 8. Sorry if this is boring. You can fast forward. And then we have negative 16 equals 16y, which means negative 1 equals y. So that's our point. 4, negative 1, that's good enough for me. So go over to 4, 1, 2, 3, 4, down to negative 1. So you can see this is a fairly shallow you know, it's a fairly shallow, I did that math wrong. Let's fix that. As I say, this doesn't look right. I know it's shallow, but it's not that shallow. See, it's just like class, guys. All right, so let's fix this. So it's not 8 times 2, it's 16. Nobody told me. So it's 32, and then that's -2. So let me just fix that if you're copying that down. So that's supposed to be 16, 32, -2. So we have the point 4, -2. So that's 1/2 of our parabola. You can mirror on the other half. So I would have the point -1, -1.8, -2, -1/2, and -4, -2. So it's a very shallow parabola, but you can still see it. I'm going to connect it. Okay, and you can see that it creates a parabola. If I were to be able to measure, if I could measure from this point to the focus and also the directrix, I would measure, and I have 1, 2, 3, 4. And I measure over here, and I have 1, 2, 3, 4. So it's the same distance, and that's essentially what a parabola is teaching you. All right, so you can see in this example, they're asking you to just write it in standard form. You might have questions that stop here, and then you might have questions that ask you to write it in standard form and then also graph. So this will be a good way to help you with graphing when it's not already in standard form. So the first thing you want to do is to isolate the variable that's squared. So for us, our squared terms are our x's. So anything that doesn't have an x, we're just going to move to the other side. So I'm going to end up with x squared plus 10x equals 4y minus 1. So far, I have all of my x's or all of my variable that's squared by itself, and everything else is on the other side. Now I need to complete the square. So we do this to make sure that our left-hand side can be written as a binomial squared. Hopefully you remember this a little bit. If you don't, here's a quick little rundown. You take whatever your b term is, divide it by 2, and square it. And you're going to add that to both sides. So we're going to add to both sides. So when you do that, for us, you could do this little bit of work in the middle row here. You have 10 over 2 squared, which equals 5 squared, which is 25. So we're really going to be adding 25 to each side. When I do that, I have x squared plus 10x plus 25 equals 4y. I'm just going to do the -1 plus 25 and get minus 24, or plus 24. So now we need to factor. So you can either remember your shortcut, or you can factor this thinking about what numbers will multiply to 25, add to 10, and it's 5. It's always the number before you squared. So on the inside here, we're going to have x plus 5. And on the right-hand side, remember, we always want to try to have numbers in the front that are multiples of 4. And if you look at both of our terms, we can factor a 4 out. So we have 4y plus 6. And that is now in standard form. You have your binomial squared, and then you have your other binomial with the terms in front. All right, and for our last example for this video, it's writing the equation when you are only given a vertex and the directrix. So the first thing I would suggest is to, first off, make sure that you know which direction this is going, and I'll just tell you this is a vertical axis of symmetry. And you would have known that if I did not cut the graph away. So that's something that will be given to you, a vertical axis of symmetry. So that tells us that our x is the term that's being squared. So our standard form looks like this. The x minus h squared equals 4p times y minus k. So that's our standard form when we have a vertical axis of symmetry. So we can fill in the values that we have here. We definitely know h and k. So we would have x minus our h, which is 3, equals 4. We don't know our p yet. And then y minus our k is 0. You don't really need to write it in there, but you can. And then our directrix. So remember, that's our horizontal line. That's so many units below our vertex. So if you think about it, going from 0 to -2, that means that our p-value is 2 because it was 2 units away from 0. So we get that from our directrix. Now the only thing that you would have to do is to clean this up a little bit. So you have x minus 3 squared equals 8y, and that would be in your final form. So for this, remember the directrix, that's telling you how many units below your vertex. So if it's -2, that means we went 2 below 0, so our p-value is 2.